Let's look at example 3 of the Power Functions handout. As mentioned before, I strongly suggest you watch and take notes down of the Khan Academy videos on intervals and interval notation and polynomial end behavior. I will be providing a link to those in the description of this video. So we have this example 3. They give us these functions, and they ask us to write each function in the appropriate row of the second column of the table. Give reasons for your choices. Of course, the table in your handout is much nicer, but this is just a rough draft. Okay, so basically they're giving us these functions, and they're giving us this behavior for each of those functions: 3 to 1, 2 to 4, 2 to 1, 3 to 4, right? Quadrants. So as a point of reference, right here I'm going to make a short small sketch of the quadrants, and let's label that quadrants 1, 2, 3 and 4. Okay, so if they tell us that the end behavior of the function is moving from quadrant 3 to quadrant 1, then we know that this is an odd degree function. It's moving from quadrant 3 to quadrant 1, and we also know that the coefficient is positive because it's moving from 3 to 1. So let's write the reasons for us. So for this, right? Positive coefficient. Good. So we know it's an odd degree function. It has a positive coefficient. So let's look for an odd degree function. Okay. Well, here is 1. So, and it's to the power of 1, and it has a positive coefficient. So let's write this down in this column: y equals 2x. Let's see if there's another one. Okay, even degree. Well, here's another one with a odd degree function, and it has a positive coefficient. So this is also another one that fits this end behavior: y equals x to the power of 7. Let's see if there's another one. Well, here's an odd degree function, but it has a negative coefficient. Since it has a negative coefficient, we know it's going to move from 2 to 4. So it's not this behavior. So this may be useful for another one of these. Once again, same thing, odd degree but negative coefficient, so we don't need that. Even degree. Okay, so that's it for these two. Okay, so now you saw how we did the first example, the first row. Let's get started on the second row, and then you guys can complete the rest. So we have quadrants 2 to quadrant 4, right? So look, quadrants 2 to quadrant 4. Let's do a small one here, so I don't have to move up and down. 3 and 4. So it's moving from quadrant 2 to quadrant 4, quadrant 2 to quadrant 4. So we know that if it moves from that quadrant to quadrant 4, we know that it's still an odd degree, but it has a negative coefficient. So which functions would match this description? Well, you look up here at the examples that we have, and so far I would say that odd degree, negative coefficient, this is one example. Here's another example: odd degree, negative coefficient, and that's it. That seems to be it. So you write these down. Okay, if you already you can always do this, right? Pause the video and try it yourselves. Y equals negative 2 over 5x to the power of 9. Okay, there's a negative there. It's not too obvious. Okay, complete the other two. Maybe pause the video and see if you can get the answer for these. Well, so here are the answers for the other ones. Okay, so we know that it moves from quadrant 2 to quadrant 1. So if it's moving from quadrant 2 to quadrant 1, we know immediately that it's an even degree function and that it has a positive coefficient. So here's the description: even degree function, positive coefficient, and these two match that description: even degree, positive coefficient. And the next one, it's moving from quadrant 3 to quadrant 4. We know it's an even function, but it has a negative coefficient. So even degree function and a negative coefficient, and these two match that description. Now with regards to example 4, I would like you to do that yourselves. Any questions that you have, just see me in class and don't forget to subscribe.